what ways do you think that the transition to these digital PLCs aligns with the broader industry trends? Do you think it's, because everything is going automated and everything is remote now, and I don't want to put words into your mouth. So go ahead, Eric, we'll start with you on this one.
Sure, it's a lot of it is just access to data, right? Data that has been around, maybe, right? They've had been collecting these data, but now having that access to quickly visualize this data, do quick computations on this data, and visualizing it either in a mobile platform or in a nice screen really is key beneficial. And then the flexibility, like I mentioned earlier, of having wireless technology, so like IoT. A lot of the sensors, even as you're buying them today and you're setting up your cells, a lot of the sensors are capable of sending wireless data or data over various protocols, like for example MQTT. Without having hardwire connections, we have data flowing from different centers and different cells all to centralized PLCs, so we could visualize the data and actually actuate things using our phone.
All right. So I'm just trying to understand this. So would you say that that digital PLC is kind of acting as a sheriff in a computer sort of thing, like directing the data from here to there, or
Sure.
maybe Ted can address that. Eric, whoever wants to address it. I'm just trying to understand for myself.
In our case, the PLC itself is acting almost as the computer, right? So we're doing the calculations and visualization all within the PLC. Even some PLCs now have a little touchscreen HMI built into it to show these little HMI to show this data, or you could blow it up to a bigger HMI or send it to your phone. But they do work closely with PCs on the factory floor to store that data.
Maybe just adding to his what he talked about, which I agree with everything he's talked about, especially in regards to the data and being able to display it on the phones, iPads, that sort of thing. That is a big deal. It's the trends these days are all about the data. It's generating data and it's using data. For instance, a certain outgrowth we've been seeing out of this transition is artificial intelligence, machine learning. Machines analyzing their process and getting smarter and smarter and running it faster and better. So that requires a lot of resources. And so a digital PLC, if it's running on a PC platform, number gives you more resources to do that sort of thing or to do
Mhm.
local analytics. But then it's also important to have access to greater computational power to run uh, larger models, but also to provide data for analytics for your decision makers to be able to see the process, visualize what's happening with it. So a digital PLC platform allows that transfer of data and that analysis, and that along with that, there is another key piece, I think, to this industry 4.0 transition is security. You're moving all this data around, it's on a network. You've got to make sure that you protect that data from those who would take it and use it for their own nefarious purposes, or to ride the network to go in and cause issues. Unfortunately, we need the networking. That's an absolute requirement. But making it safe, that's something that it's a very key aspect with this digital PLC transformation. It was hard to protect data from a conventional PLC. It's much more challenging, requiring additional layers of hardware. A digital PLC platform gives you far more opportunities for cybersecurity and protecting your data.
And Ted, that is an incredibly important piece to this whole puzzle because manufacturing, especially where PLCs are used mostly, is the number one target for cyber
Mm-hmm.
attacks in the States. So it's a really, really important part.
Mm-hmm.
So why don't we then move on to the challenges or the obstacles that companies typically encounter when they're integrating these digital PLCs into their systems? And because I'm sure that while we'd like things to go completely smoothly, there's always challenges when we try something new. So why don't we talk about those challenges and then how are those challenges overcome for these companies?
Working with small to medium companies, we've had an initiative last year to kind of bring this digital technology, and maybe not necessarily digital PLCs, but just overall digital manufacturing technologies to about 10 small to medium companies here within the Midwest region. And working with these companies, it really comes down to resources. The expertise it takes to integrate some of this technology is still on the advanced level. And then the other one is really the infrastructure. So the resources of human resources, right? And then also the resources as an infrastructure. So some places don't have the internet connectivity. They don't even have Ethernet wired out to a lot of these machines. So getting over those hurdles are really it's a challenge, but a lot of companies are kind of steadily getting into it as they're adopting this technology. They're running out new lines to the machines. They're doing training for operators and overall just engineers and service techs to understand not just ladder logic, but also C++, Python, so on and so forth, and be able to implement some of this technology within their factory floors.
The infrastructure was one I was thinking about, in that, especially if you look at, say, the automotive industry, who's been doing conventional PLCs for an extremely long time, and I'm aware of many who have important systems that were installed pre-Ethernet. They don't have Ethernet ports, and they really don't want to go through the trouble of trading those out, especially as they have spares and backups of these things. But they have the need to collect the data and to do the analysis. So, and they've got barcode readers that are serial, et cetera, et cetera. So, how to take this information and digitize it is definitely one challenge that we've had. For a while, there was resistance to the idea. That's not a PLC. I don't want to use that. But that I'm glad to say I've seen that attitude change quite a bit, or even over just the last 4 years or so. I kind
I
of think
agree.
maybe COVID kind of helped push that out, that, hey, we need to be able to, view our stuff from home if necessary,
Yeah,
that sort of thing, And so I think that attitude has changed some, fortunately. But what Eric was alluding to, kind of the talent pool. I mean, yes, we've got engineers coming out that know C, whatever, but a lot of your support staff is much more comfortable with the traditional ladder.
hmm
So how do you bring those together in a way that you can use their talents and their talents is definitely a bit of a challenge.
Right. And the different networking abilities, I guess, would really come into play
Mhm.
with trying to get people on board, because like you were talking about before with the security, um, I think when you're going from something that's hardwired
Mhm.
to something that's floating in the air, there's that hesitation. And I think that the 5G is a really good example of that's a really secure way to network things. At least the systems that are coming out now seem
Mhm.
to be working well, especially when Eric was talking about where they don't even have Ethernet lines run,
Yeah.
or the ability to have Wi-Fi wherever they are. So it's nice that we have these technologies and that all of the aspects of the automation and the interconnection is they're all coming together. Which is pretty cool. So, how do you see the future of these PLCs, these digital PLCs, evolving in the next few years? And then, what opportunities do you foresee for businesses in this space as we continue to advance the technology?
Oh boy, that's a pretty big picture question. um, but I think that overcoming one of the obstacles we mentioned, kind of the talent pool. I think you're going to be seeing more and more, um, yes, hybrid software systems where, for instance, I know of a few companies where, yeah, they're doing the ladder to run the machine, but then what they can do is you can take your code, you can write it in C, Python, whatever, and you can actually encapsulate it inside of an instruction and run it inside a ladder. So you're kind of getting the best of both worlds. You're kind of getting the talent and the ease of writing a complex function, but then being able to run it in an environment that someone who's troubleshooting can look at. So I think we're going to continue to see the evolution of more of those kinds of tools, I think, at least for the next several years. Maybe eventually we'll get to the point where you're not going to need ladder to do sequential machine control anymore. And so that could be another evolutionary path. I mean, I know in some cases you can do that already. It's just it can be tricky to troubleshoot that, and you always got to keep that in mind, right? So that's one thing that I can see. I think we'll begin seeing. I mentioned to you a few days ago, but as we were talking about this article about this concept of the virtualized PLC, where you take this runtime engine and it's kind of in its own self-contained thing, and then you yourself can drop that onto an HMI or into an Ethernet switch or into whatever kind of device that you need and turn that thing into a control, and so that way you can really kind of create a niche type product that, kind of on your own. I really need something that does this. Here's the control. I've already written my software that runs for it. I can drop it into this whatever and then start programming it, and so that way you're just really taking your code and making it very, very portable. Codesys already is doing that to some extent. I think we'll be seeing more and more of that type of tool.
Yeah, couldn't agree more. Really, just the integration pieces too, just to kind of add on top of that. Um, Having the ability, conventionally when thinking about PLCs and overall controls software was a lot of brand agnostic or just very brand specific software, hardware, controllers, IOs. If you wanted to use brand A, use brand A software, brand A sensors to some degree. But now with the kind of forefront of open source of different new protocols coming out, being able to communicate across different platforms and hardware is I think kind of growing a lot now, but will be exponentially growing in the future, right? So with the emerged, like what MQTT came out only a couple years ago in reality, but it's boomed within our industry, and I'm sure we're going to see many more protocols also kind of going either coming up and growing as well. Um, the ease of coding piece, completely agree with Ted on that. The ability to integrate, Python and overall language coding with more coding like ladder logic, but also bringing in object-oriented coding, more GUI-based coding, where it's a lot more easier to program, and it'll kind of help overcome some of those hurdles for users. Additionally, the generation now is being introduced a lot earlier on to stuff like microprocessors and microcontrollers. For example, Arduinos and like BeagleBones. These companies are now coming out with industrial controllers that really take the entry level microcontrollers and kind of just beef them up and bring it more to an industrial level. Um, so having users start off like in high schools learning C sharp, C++ coding, implementing that into an Arduino, and then now Arduino and overall a lot of their competitors and overall peers are coming out with these industrial PLCs that run on the same logic and same principles. We're going to see huge boom in talent that just understands and can quickly build off of the current technology.
That's a great point too.
Mhm.
I appreciate that. All right, I don't have any more questions, but if there's anything else that you would like to add or say as we're on this subject, now's the time.
The main thing I would say is that if you are looking at Industry 4.0, whatever that means for you, whether it's distributive data, distributed decision making, artificial intelligence, machine learning, there are definitely a lot of companies out there who are attempting to fill that niche, and Phoenix Contact is one of them.
And your factory space or in your shop floor environment is being ready to integrate the data, but also collecting the right data. Not collecting all the data, but understanding, going to the root cause of what the problem is you're trying to solve, and collecting the appropriate data that'll help you make those decisions. And these digital PLCs, these digital technologies really help with that piece of the puzzle. But if you're collecting all the data or the wrong data, it'll just help you make bad decisions faster. So yeah,
That's a great point.
yeah.
Well, that's terrific. Well, I really appreciate both of you being here with us today. Ted Thayer and Eric Kozikowski, thank you so much for being here. And until next time, stay curious.